Alright students, so here's the first video. If you're watching this is how to create an area model on 5 probabilities. And in this case, I'm going to start with the same example that I used during these class days. I want to go to Walmart after school. The probability that I take the orange line is 3 out of 10. The 11 bus is 1/2. The 901 is 1/5. Also, there is a 60% chance that I will see a student. So first thing I want to do is, like any good mathematician, is of course read the problem, which we just did together. And then after that, identify the events. So here I'm going to say event 1. Now I'm going to call this my transportation. That's a 1. Oops. Transportation. Now what do I mean by that? I mean transportation because the probability to take the orange line is 3 out of 10. The 11 is 1/2, and the 901 is 1/5. So it's just how I get there. So 1 again, orange line is going to be 3 out of 10. The 11 bus is going to be 1/2. And the third one is the 901, which is going to be 1/5. So all I did here was categorize my data. 1, 2, 3. Orange, 11, 901, 3/10, 1/2, and 1/5. Just writing down the probabilities next to it just so that I know what my table is going to look like. Event 2. I have the students. And here I said there is a 60% chance that I will see a student. So my two options are going to be yes, I will see a student, and no, I will not see a student. And yes is 60%, so no must be 40%. Now, like every good mathematician, we want to write these as fractions because it's easier and it means something in probability. So 60% is the same thing as saying 60 over 100, which I think most of us can simplify to 6 out of 10 or 3 out of 5. And now just trust me on this, the probability that I do not see a student, in other words 40%, is the same thing as 2 over 5. So I got the first step done. Let me just remind you what we've done so far. So 1, we read the problem. Always have to read the problem, don't forget that. A lot of times we want to start it without really knowing what we're doing. 2, we want to identify the events, which we just did right here. So 1, read the problem. 2, identify events. 3, create the table. Steps 1 and 2 are really just going to make our work easy for the table. So if I make my table, I know it's already going to look like this. Something like this. On top, I'm going to write event 1. On the side, I'm going to have event 2. And then I'm going to say the orange line, the 11, the 901, the probability that I do see a student and that I don't see a student. What I like to do is usually just to help me out is I know that the orange line, the probability is 3 out of 10, the 11 is 1/2, and the 901 is 1/5. Same thing for the yes. For the students, sorry, it's going to be 3/5 and 2/5. So now I have my table down. Now let's say I want to ask you for the probability that I take the 11 and I do not see a student. Now all I have to do in this case is 11 is right here, so I care about these. No, so I care about these. Where did they overlap? Right here, so this is a probability that I care about. How do I get that? We know the multiplication rule, and we know that the multiplication rule tells us that you can multiply them if they're independent. So 1/2 times 2/5, and now we get 2 out of 10 or 1 out of 5. So now there's a probability that I go under 11, do not see a student, is 1 out of 5. Another shortcut, or another example, sorry. Let me just move this so I have some space. I don't know what I just did. Whoop, sorry about that. let's say that I wanted to find the probability that I go on the 901 and I do see a student. Again, 901 right here, so 1/5, 1/5. That I do see a student, so yes, times 3/5, and I will get 3 out of 25. So this is the same as 3 out of 25. So last step that I didn't talk about was use the multiplication rule. To find the probabilities. Put this in the little cloud over here. Besides that, try the classwork. Good luck, do your best, and please ask your friends and ask me if you have any questions.